Afternoon, my name is Justin Nicholls and I'm from Make Architects, and I'm here to talk to you about the Old Road Campus Research Building for the University of Oxford and the concrete that is featured in that building. The client itself is the University of Oxford, and it's the Medical Science Division. They have a huge amount of research which helps fund the university generally, and this building is there to incorporate a number of different research projects. The site itself is adjacent to the Churchill Hospital, which is a cancer treatment centre. This building is primarily for cancer research, and the two of those go hand in hand. It's on the outskirts of Oxford, just tucked behind Oxford Brookes University. The site itself is earmarked for medical research, and as I said, it is next door to the Churchill Hospital. Around the site is a very lush green vegetation and planting, and then beyond that we have residential development, so that there's quite a domestic shift in the site. This is the site itself, a brownfield site built in the 70s. You can see just to the left of the slide the previous development, and this is the third development on the site. The site itself was given to us as a boundary line, and the building pretty much filled the boundary line, so we had very little scope to manipulate the form of the building, and we were really looking to maximise both the envelope and the floor area for that. Now, the building constitutes really 6 different departments, and the important thing about that is the interaction that those 6 different departments give, and the improvement in the cancer research that we're able to give from that interaction. It's important, therefore, that that building is located on a research campus, and it's very important that that research campus is adjacent to the hospital. Clinicians and academics are the same person in medical science, so you get excellent clinical care and excellent research. The organisation of the building around those 6 different departments then becomes very important, and the areas that are circled around those institutes are communal facilities which those departments use. Half of those are the typical facilities you find in offices, such as cafes, library, administration, meeting rooms. The other half is specific to laboratories, so gas rooms, specialist equipment, autoclave cleaning areas, etc. As I mentioned earlier, the mass of the building is very tight on the site. We took the footprint of the building, carved out 2 atrium spaces and an entrance space. The other important thing with that is we didn't want to express 3 cores of the building. So as you see in the slide here, the front of that building sort of slips and slides so that someone can't take possession of one wing or one floor, again to encourage that interaction. The next fundamental element of the building is the building grid. We didn't have a fit-out brief when we started the project, and we were tasked with creating a generic laboratory space that could be used for any of those 6 departments and any quantum of laboratory space within that. This 6.6 metre square grid is ideal for accommodating both office space and laboratory space. The part of the brief was to make the entire building flexible, and that's very expensive because laboratory space is very expensive to condition in terms of air, and it has a very high air change rate. So we came up with the idea of fixing 2 parts, the front and the back of the building, the yellow being the office space and the darker salmon colour being the laboratory space. The area in the middle is then flexible, so we're minimising the over-provision of any services. The next task then was to lay out that 6.6 metre grid very efficiently. This is one of the best net to grosses on a laboratory building. There are an extra set of staircases and lifts so that people can move up and down the laboratory space separately from the office space, and that's very important in terms of safety. All the cores across that building, in terms of the cores at the bottom of the slide there, are made out of concrete, and that provides the lateral stability for the frame. This shows then that very simple slab is able to be built very quickly and very efficiently. This is a £55 million building. We had 18 months to construct it. That's roughly £3 million a month, which is a very, very fast build, particularly for something as complicated as a laboratory. So it was important that we rationalised and kept those elements very simple. Over the top of this concrete frame, then we start overlaying the circulation of the building, which you can see in the paler colours around the cores, introducing that laboratory, office and flexible zone. And then you can see here how that gets populated, and on the right hand side you can see how that office space is encroached down towards the core of the laboratory space, and demonstrating that flexibility and how different departments occupy that. It also starts to give you a bit of a scale for the building. This is the laboratory space. They're very generic, so that one can undertake different research programs in there at different times. Some of these will run for 3 or 4 years. Obviously the facility stays there for much longer than that. We have more specific spaces, typically in the basement. So we have biomedical engineering. So this is where they make small elements that go inside you, like heart pumps and the like, and also where they amend standard equipment for particular research projects. This person here is researching into using sonic waves to kill cancer cells. So things like vibration become very important here. So we spend a lot of time talking about putting them in the basement and making sure I had a very stable slab to work from. And then he brings in this lovely old timber desk that's very wobbly. But you try. Moving out to the facade of the building, this really was derived from 3 different elements: the internal use, the shading, and the planting around the site. As I said earlier, we didn't have much room to manipulate or develop the massing of the building, so it had to be done in a very sort of thin cladding zone. This shows you the components that the facade's made up of. So we modulated with the glazing, the different colour green, aluminium, the perforated aluminium and the louvers, picking up the reflections of the planting behind there. Around the back of the building you see that the facade is much denser in terms of its solidity and in its colour. Those are the 3 cores sticking up, and then as we move around the building the colours get lighter. This is on the south facade, so it's quite heavily louvered in terms of shading. You can see in the middle where, coming along the floor plate, the cladding steps down towards the office zone, where the offices are where we have much more glazing in the office than we do in the laboratory. Coming around the front where those louvers start to peel off, again the colour gets lighter until we get to the entrance where we have the lightest greens and the maximum amount of glass. We're east facing here with quite strong planting behind to provide any morning shading, and then the red accent colour to identify the entrance. Moving on to the centre of the building, there are 2 main spaces we call the street and the courtyard. They provide interaction space both for this building and the rest of the campus. There's not a huge amount of facilities there for people. We called the main space the street because we wanted something much more active, and the courtyard is something much more passive. The street also ties us back to the quad, going back to the original Oxford and Cambridge building typology, if you like. So on the left-hand side we have the main entrance, which is single story in height. It's quite compressed, and then you move through into a larger open space. In that space we then have the main staircase, opening up to the roof lights at the top, and on the right hand side of the slide we can see the second entrance, which is very important because that's where the researchers come from the other 2 facilities on the site. The key move with the staircase and the atrium space was to use concrete. So we anchor the building down in the centre, we give it a level of gravitas that, as you see from the facade, is a kind of counterpoint to that, and it gives it a sort of solidity. The use of concrete enables us then to be quite playful with the staircase itself. We've got a very large cantilever on the first floor, and then the layout of the staircase is really a function of marrying the main entrance with the second entrance coming behind. So in the bottom left-hand corner, the gentleman, the model with the walking stick, is coming up the ramp from the second entrance. That ribbon wraps around and becomes the first flight of the staircase, which goes up to the first floor. The staircase then moves to the right, up onto the second floor. As we come up to the top of the staircase, the concrete then continues around and becomes the upstand around the slab edge of the atrium. The concrete here and on the staircase is the same height, so it's continuous, and that forms the balustrading edge to the laboratories, which means we didn't have to strengthen the glazing above, so we got cost effectiveness out of the glass by using the concrete through there. It also then ties the whole space together. This is the view looking from the second entrance on the right hand side, the staircase sitting there back towards the left, and the main entrance in the far left. The other very, very important aspect to this is when you enter the building, you look straight into the laboratory space. Most laboratories you enter into a reception and an office, and the laboratory space is tucked away. We also felt then that the contrast between the concrete and the solidity of the concrete in the atrium worked very well against the very precise nature of the research and the scale of which that research happens, and the equipment they use, such as glassware. This shows the ribbon in its entirety. It starts down the right hand side at the second entrance, winds its way up. It is continuous all the way up to the top of the building and then back down again, so that there's no break. We've got a very gentle curve on the radius on the corners, and that also descends down into the basement, almost making like a cave. Looking at the working drawings here, it gives you a bit of an idea of the size of the cantilever, which is about 9 metres. When we started that, the concrete contractor said that it actually wasn't feasible, and actually wrote to us and told us that. I think they meant it wasn't feasible for the budget that they allowed. So we made some minor modifications on the structure. You can see in the bottom right hand corner some work that Price & Myers did, the structural engineers, on testing that, and the red area in the middle shows you where most of those stresses occur. This is then Byrne Brothers working very hard at the formwork. It's very, very important to remember that these guys that are on site really do craft this. There's a guy there with a set square cutting a piece of wood, going in to construct that formwork. So the quality that you get is all really down to that person in there. We work very hard to try and make sure that we've rationalised the design as much as possible, and then enable them to focus on the things that we really care about. This is the staircase as struck. You can see the treads in there with the timber protection on before the glazing goes in, and obviously the laboratories. One of the important points that we considered right from the outset here is that all of this exposed concrete is off the critical path. So the flat slabs go in nice and easily. We get the top slab on, we can start putting the cladding on, we're watertight, whilst they're playing around in the atrium, so they can take much greater time, much greater care over getting that right. A couple points to note here. The formwork was a phenolic coated plywood. It was oversized plywood, which I think came from Canada, and we used self-compacting concrete, and I think that was because we had quite a lot of reinforcement in that staircase itself. The other point to note here is the horizontal line that goes across the stair and also down the ribbon along the sides. That came out of a long debate with the Byrne Brothers, and was a function of how you cast the ribbon against the floor slab. So the bottom half gets cast first, the top half gets cast second, and we decided to carry that on down through the staircase for continuity reasons. We think in hindsight that was a really good move, because I think it makes it much more dynamic. The vertical joints are then butt joints, very tightly put together and kind of underplayed. We didn't do a huge amount of finishing to the concrete. There was a little bit of bagging in of a few blowholes, tiny bit of sanding, but other than that it's kind of as struck. The second interesting element on the staircase here is the soffit in the kind of salmon pink colour. These are actually fabric panels that provide acoustic attenuation, but what we really liked was the juxtaposition of the delicate fabric against the harder concrete element, and it also really emphasised the ribbon of the staircase rather than the form of the staircase. Likewise, we carpeted the treads of the stairs, so we've got that fabric on both the soffit and the top of the stair. In addition to that, we added a small stainless steel handrail. That's the only element really that gives you a human scale or an element to touch, and again we like that juxtaposition. We managed to integrate all the lighting, so all the conduits cast in, you can see a light fitting down the left hand side, and we filled the bolt holes to about 10mm from the surface. As you move up the staircase then, you can start to look back down and you get the extra large spaces at each level, which is now occupied by seating. So we're trying to get much more interaction up through the atrium, not just down on the ground floor. This shows then a little bit of the juxtaposition between the kind of solidity and mass and the rawness of the concrete against the very sort of precise but slightly messy nature of the laboratory space, and the difference in scale that you get with the equipment that you use in there and the main atrium. This is standing down on the ground, so this is the cafe breakout area where most people sit. The first floor of the first landing of the staircase is also very interesting because you're actually standing right in the middle of the atrium. So you get a very different experience there than you do on other parts of the staircase, and so because the stairs flipped rather than continuous vertically, you are able to get those spaces. The second space we called the courtyard. Now this is much calmer. You can see the stair on the left hand side here goes straight up and down. It's much more conventional. It uses the same construction techniques and the same ribbon going around the space. It goes down 4 stories, so we're really bringing the light deep down into the building. You get to see some of that sitting here. And this is intended to be much more contemplative. So on the floor, instead of tiles which you have in the street, here we've got a soft linoleum finish. And the intention here is that you'd end up with sofas and a kind of seating area. You can see the staircase which stacks on top of each other, so much less, nowhere near as dynamic as the other space. Looking up again, you see your eye very much goes towards the detailing of the stairs here, I think, whereas in the other staircase, it's very much more about the spaces. Not a bad place to stop and have a phone call. And I think one of the biggest compliments we have about the building is that nobody ever uses the lifts. People always use the stair, they enjoy walking through there, and I think that's kind of testimony really to the design. Thank you very much.